Okay, still on this problem. I had to make that last one short. I think this is a little better. Okay, yeah, so what should we pick for K? So we want to, now, why don't I ask you, if we have 12 people from a set of, bit much bigger set, like 500, how many of those 12 would you want to say they were voting for A in order for you to claim that that the probability that a random person from that large population, or the percent of the total population, is at least 2/3 or greater than 2/3? Now, probably a lot, right? So 2/3 of 12 is 8, but 8 isn't very convincing. I mean, 8 seems like, you could have about points, you could have about 60% instead of 66%. 60% could very likely give you a total of 8 out of 12, even 50%. Now, these all can be calculated and need to be sometimes so that you can specify what your test is really doing. Okay, so we're just going to say something so that we can calculate a few more. I'm going to say, let's say 10, okay? I think 10 is reasonably safe. 9 might be pretty nice, but let's just say 10. So for example, suppose so you can pick whatever. You could pick like 0 or 1. That would be really silly. It'd be a bad test. Or you can pick something too high, like 12, and that would probably be a bad test. So we'll see. So suppose we pick, so let's just start by putting in some numbers. Suppose we pick K equal to 10. Okay? And actually, the way I wrote it here, with y star greater than K, maybe I could make it like 9.5 to make it clear that I want to include 10, or I could just write like this. I'll write it like that. So the rejection region is the set of, is going to include any y star where y star is greater than or equal to K. Okay, so, and K is 10. Suppose we pick K equals 10. All right. What can happen? What are the outcomes of the test? How many outcomes are possible? How many distinct and different outcomes are possible? This could mean several things, so I got to be clear. All I mean are there's 4, okay? Possibilities are, so there are 4. So there are 4. There are always 4. 1A, what could be true? H0 is true. And we pick H0. Test indicates H0. Now, what does this mean? If we get a little more clear about this based on what we said, P is less than or equal to 2/3, and this y star is strictly less than K, equal 10. Okay, that's one possibility. B, H0 is true, and test indicates HA. So H0 is true, P is less than or equal to 2/3, and test indicates HA. So this means y star is greater than or equal to K, equal 10. When this happens, when the null hypothesis is actually true, but your test tells you to pick the alternative hypothesis, your test made a mistake. Okay, so this is called an error. This case is called a type 1 error. Okay, it's always called a type 1 error. When H0 is actually true, but you conclude the alternative hypothesis is true. Can it happen? Yes. P could be a half, and you could still find 10 or even all 12 of the people you picked could report that they would vote for A. C. HA is true. And test concludes HA. Well, this is not an error. This is good. HA is true. P is greater than 2/3. And this would happen if Y star was greater than or equal to K equals 10. Finally, HA is true, but test points to H0. In this case, P is again greater than 2/3, but Y star was less than K equals 10. This is an error. In this case, P is greater than 2/3, but the way you have your test set up and how the sample went, only 9 or fewer of the 12 said they would vote for A, so the test picked H0. So this is called, this case, this is the only other kind of error. This is called, I bet you know, a type 2 error. Okay. Now, okay. Now, for this test we just made up, let me ask you some questions. So for the test in hand, for the test we just made up, above, suppose the actual P is equal to, let's pick something easy like a half. Suppose the actual P is a half. Find so in other words, H0 is true. So if H0 is true, P is a half, H0 is true, okay? So, do I want to do this? Yeah, okay, let's just do this with P as a half. So find the probability of a type 1 error. Okay, so this is just an example. Now, we never know this really, right? So this is a little bit fabricated. We're just going to see what the probability of a type 1 error would be. Well, solution. Probability of an error in this case is, well, if P is a half, this is equal to probability, choose HA, given H0 true, which in this case is equal to probability y star is greater than or equal to 10, given p equals a half. Okay. So I'm a little concerned. Let's see, for the test above, suppose the actual p equals a half. Find the probability of a type 1 error in this case. So the probability of an error when, let's write it, let's clean it up. When p equals a half, let's take this out. We don't know this. You see, this is why I'm a little confused, because it's a little bit unreal. You wouldn't know that. When p is a half, is the probability y star is greater than or equal to 10 given p is a half? But we're just trying to get a sense of these numbers. But this is equal to, well, this would only happen if we get 10, 11, or 12 successes, right? So this is 12 choose 10. And over here I have 1/2 to the 12th. They're all going to be 1/2 to the 12th. Plus 12 choose 11. 1/2 to the 12th. Plus 12 choose 12. 1/2 to the 12th. This is equal to, let's see, 12. So this is 66 plus 12 plus 1. So that's 79 over 2 to the 12th, right? 4096. Okay, so pretty small chance. It's about almost 80 over 4,000, which would be 1 over 50 about. So this is roughly 1 over 50 or a 0.02 chance of a type 1 error. Okay? Okay. So this is pretty good. This is about 1 over 50. Pretty small chance test makes an error. Type 1. Okay, so we're just getting a feel for this. Okay, all right, I'll stop the video. We'll start again in a second. So.